Hi there, I'm Claire Pittman. I'm part of the public engagement team, and welcome to the Stormwater Master Plan public meeting for the upper watersheds, which include Upper Comite tributaries and Redwood Creek watershed, Sandy Creek watershed, and Upper Amite River and tributaries watershed. Thank you so much for joining us. We have a lot of great information to cover. At the end of this presentation, we will be taking questions, and how you will do that is by clicking the Join the Podium button, and then you'll be able to submit your questions and your comments. So you can do that throughout the presentation. You don't have to wait till the end, and those will be captured. How this is going to work is the project team is going to go over a presentation. And during that presentation, we're going to show these amazing models, and they're better if you enlarge the screen. So in order to do that, you would click the segmented square at the bottom of the image that is playing, and that will enlarge the screen. I want you to notice, though, that the Join the Podium button does disappear. So in order to get that button back, you'd click that button again, it would reduce, and you can ask your question or leave a comment. So at this time, I'd like to hand the mic to Melissa Kennedy, the Stormwater Master Plan's project manager and our amazing fearless leader. Melissa?
Thanks, Claire. Hi, as Claire said, I'm Melissa Kennedy. I'm the project manager for the Stormwater Master Plan for East Baton Rouge Parish. And before I get started, I want to introduce a few people who are joining me this evening, some who will be presenting as well. We have Brandon Campo and Stoka Brown from CSRS, and they'll be talking about the modeling and the evaluation they've done for the northern watersheds. We also have Jeff Dowdrick on the line from HNTB. He is our technical lead for the entire project. So what is the Stormwater Master Plan? Basically, it's a document that we're preparing that will identify the flood-related risk and vulnerabilities. And what we mean by that is where it's flooding, the extent of flooding, the depth, and what are the resulting damages as a result of the flooding. Then the plan is we will provide a series of projects that will mitigate that risk of flooding, and these will go into a capital improvement plan. We will also be providing policy solutions and recommendations to the codes and ordinances to reduce and prevent future flood risk. And Stoka is going to talk about that later on in the presentation. Our overall focus on the project is really to mitigate the damages for many of the people in the parish, not necessarily looking at individual properties, but we're hoping that through all these projects and policies, we will be able to mitigate the risk of flooding for everybody. So the parish was broken up by the team into 11 different watersheds. And that's what you're seeing on this map here, the parish boundaries with these 11 identified watersheds. And what do we mean by a watershed? We basically mean an area of land on which that rainfall falls that then drains to a single point. So these are the 11 watersheds we've identified. And tonight we're going to talk about the 3 that Claire mentioned. And these are shown in yellow, kind of popping out of that area of the parish boundary. And you can kind of identify where these are through some of the major roads, US 67, number 1, Port Hudson Pride Road, way up there to the north, Pierce Road, etc. So that's how you can orient yourself on where we are. So I'm just going to give a brief overview information about the watershed, and then I'm going to turn it over to the modelers to talk more detail. So what you're seeing here is a LiDAR map. And what does that mean? That means light detection and ranging. It's really a fancy way of describing and showing the topography and the elevations on this map. So the boundaries of the watersheds are shown in red. And then the different colors are different elevations. The brown elevation is the higher elevation in these watersheds. Yellow gets lower. And then as you get into the green and to the blues, those are the lowest areas of the watersheds. I'd like to point out in this area of the parish, we do have a lot more topography than we have been seeing in some of the other watersheds, especially at the southern end of the parish. So this just gives you an orientation of where you are and the elevation. And what I want to point out here, this is the FEMA flood map. And what you're seeing here are the flood zones as identified by FEMA, the 100-year flood zone. And what does that mean? That really means it's the flood event that has a 1% chance of occurring any given year. It does not mean that that flood is going to happen once in 100 years. It's just a probability of that flood happening 1% any year. And so what you see here are the dark blue A zones and light blue. The light blue are, these are all flood hazard zones, but the light blue identify those flood zones that have a designated base flood elevation assigned to them. The other darker blue areas, they're called A zones. They designate the area of flooding, but they do not identify specific depths. And you can also see here that the area of flooding somewhat corresponds to the elevation map that I showed on the previous slide. As we get lower in elevation, we find we're getting closer to those areas that flood and correspond to the streams. So this map is essentially the drainage system of these watersheds. The white dots that you're seeing, those are the bridges and culverts that we identified through our data collection effort. And then the blue lines represent all the channels and the creeks. The yellow lines indicate the flow of water in these watersheds. So on the left, the upper Comite tribs and Redwood Creek, they all drain to the south into the Comite River. The middle one, Sandy Creek and its tributaries all drain south and end up in the Amite River. And then over to the right, we have the Amite River and tributaries. Those channels all drain directly into the Amite River. And again, what you're seeing in red are these watershed boundaries. I would like to point out that these assets or these structures that we identified, these are just some of the structures that have been identified throughout the watershed. We also did an intensive data collection effort, not only on culverts and bridges, but on the subsurface system throughout the parish. It just so happens that this area is a little bit more rural and does not really contain a subsurface drainage system. But as part of that effort, we did survey over 60,000 assets, catch basins, pipes, manholes, etc. So what you're seeing on this map is some of the data collected by the parish. This map shows areas of concerns with flooding or drainage related problems. The little stars represent 311 calls, which are where people have entered their concerns about drainage, repetitive loss, and severe repetitive loss properties. They also represent areas where people have submitted photos and emails telling us about their flooding problems. So all of this are shown on this map. And we used this information when we did our flood hazard analysis, evaluating the areas that flooded and what we could do to help reduce the risk of flooding. And again, folks from CSRS will talk about that further. In general, for the flood hazard analysis, we took a tiered modeling approach. We basically have three different models that we're looking at, three different tiers. The first one is a regional model, and that covers a very large area. It covers the entire parish, as well as areas contributing into the parish from outside the parish, and the area of the parish that contributes outside of it. It's a very large model. It's a high level resolution, and it's really used to evaluate those larger, longer duration flooding events. And it's really used also for planning level purposes. The second level is a tier 2 model. This is a watershed level model. So that map I showed you previously that showed you all those 11 watersheds, each one of those is this tier 2 level model was developed for each one of those. And what you're seeing in this image is an image of the actual clay cut model boundary. And those models are a little bit better resolution. And those are used to evaluate a neighborhood level flooding. And we use those for planning and design. And I just want to step back. On the tier 1, it's a low level resolution model. Then we get into tier 3. That is an even more detailed model, and there are multiple of those within each watershed. What those are used for is more of a street level resolution flood mapping. And again, that can be used for planning and design. But I do want to point out for this area, the tier 3 model really focuses on the subsurface system. And since we didn't really have a subsurface system in this area, we did not utilize a tier 3 model. So what you're seeing on this slide is kind of a representative of what the model looks like for each of these different tier levels. So on the previous slide, that red square you saw, this is that red square area and how it's represented in each of those models. The tier 1, again, a lower resolution, a bigger grid spacing, meaning a bigger area that each of those grids identify, and it captures the major structures and major streams. The tier 2 model, again, is a little bit higher resolution. You have a much tighter grid spacing, and it's capturing many more of those streams as well as the structures, more bridges and culverts in that one. And then the one on the right here, the tier 3, again, that's capturing the actual subsurface system. So what you're seeing here and the blue lines and the dots, those represent the pipe network and the catch basins and manhole inlets. And again, this we can get down to a very small area in analysis. So now I'm going to turn it over to Brandon Campo, CSRS, who's going to talk us through the modeling that was completed.
Yeah, thank you, Melissa. As she said, I'm Brandon Campo. I had the great privilege of being one of the modelers for these areas. Here we're looking at the 13-inch and 24-hour event. This is roughly equivalent to that 100-year storm that we were looking at. And we're in the Upper Comite tributaries model. Redwood Creek is the main stream that you see. The stars on this map are concern areas that we identified using the data that Melissa had talked about, both the complaints and our results from the modeling. So here the blue is the water flooding this area. So in this slide, I just wanted to talk about how the model results help us to determine a few things about these watersheds. So we can determine channel and bank flow rates. We can determine flood extents to make sort of similar maps to the ones from FEMA. We can assess the depth of inundation for individual structures. And using that depth information, we can assess damages. All of this we kind of push together, and we're able to identify areas where solutions are most needed and then evaluate those solutions on how they perform. The area in yellow here in the center of the bottom of the screen is an area that we're going to zoom in on later, just to give you a better idea of the model results, how they look, and how we are using them. So we can continue on now to Sandy Creek, the second of our 3 watersheds. And in Sandy Creek, I do want to point out, you'll see basically 2 phases of flooding. So the first is what we're seeing right now. Rain is falling on the model in the parish. You can see the parish line is dotted up there towards the top of the screen. So we have this first part where rain falls within the parish, it concentrates into the streams, and that begins to flow out. And then there's a second part that should start happening in a little while, where the out of parish area, the water that fell there and concentrated into those streams, all comes down through Sandy Creek and Little Sandy Creek. So that's starting now. You can see that there isn't much water up on top of our topography, but down in the bottom we have a lot more. And you can kind of see it flooding now towards the southern part of the screen. So Upper Comite has a similar thing going on because both of these watersheds have a very large out of parish area. And we'll hear a little bit more about that later on. You can see similar areas here in Sandy Creek that we'll take a look at a little bit later. And here's the upper Amite tributaries model. This model is much, much smaller than the other two that we're looking at today. And not only that, but the area doesn't have very many roadways or structures. So we actually didn't identify any potential concern areas here. And part of the reason for that is that flooding in this area is more strongly controlled probably by the Amite River. And the Amite River is not included in this model. The Amite River is included, however, in the regional model, that Tier 1 model that Melissa mentioned earlier. So those impacts will be assessed, but they're just not, we're not seeing those here because the local flooding from a rainfall event on this watershed, it doesn't cause a big impact. So now we're moving into Area 1, and again, we're in the Upper Comite tributaries model. Redwood Creek is the main channel in the center. And notice this other one coming from the top left of the screen. That's Doyle Bayou, and it empties into Redwood Creek right about where the word wide is on the screen. A few things that I want to note here. Like I was saying, we have this very large contributing drainage area. So at this point, it's about 80 square miles, and 64 square miles of that is outside of the parish. The floodplain here at the top of the screen is relatively wide, and all of that has to basically get funneled down to a relatively narrow opening at Plank Road. And that is by no means a small bridge, but it's a very large drainage area that we're talking about. So the water has to get funneled down, and that causes a drop in water surface elevation, which lets us know that there's a constriction point there. Now this red arrow towards the top right of the screen is pointing out an area where you can see these white lines on the screen are showing which direction the water is going. There's water actually exiting the model, exiting the floodplain up here. So it's like a natural overflow route. So one thing we might be able to do, in addition to increasing the capacity of the crossing at Plank Road, the yellow one at the bottom, is we could enhance the ability of the watershed to drain through this area marked with the red arrow. So next we'll move on to Area 2 in Sandy Creek. So here we are, we're near where Piers Road and Stony Point Birch both intersect with Liberty Road or Highway 409. So you can kind of see the two phases of flooding, that first one and now this second one. And I hope this video will loop so we can point out, but Liberty Road in this area runs along Sandy Creek. So that's the large channel that we see kind of in the middle right of the screen. There's this crossing at Stony Point Birch that we could potentially improve. But yeah, just there, we saw it again. But the water in Sandy Creek wants to empty into the stream to the left. It wants to empty westward. Right there, you can see it again. So this is another spot where we could potentially restore that function to the floodplain. Now, I do want to note that maybe the people living over on the south side of Piers Road might be a little bit concerned if we let water come from Sandy Creek and enter the smaller stream that goes past their houses. But the 2D models actually allow us to test that solution and assess if there will be negative impacts in other places. Now we'll move on to Area 3 in Sandy Creek. So here we have another same storm. We're near Sandy Creek and Duff Bayou. Sandy Creek is coming in from the upper left corner of the screen. So at low flows, the natural drainage pattern in this area is actually for this little finger stream to go northward through the culvert that the red arrow is pointing to, that little yellow line that the red arrow is pointing to. It would go through that and up into Duff Bayou and then southward. But at this confluence of Duff Bayou and Little Sandy Creek, the water level gets so high that culvert can't flow out anymore, and it actually backflows. So water is coming from the floodplain into the area behind this roadway. So a potential thing we could do to counteract that would be to add a flap gate at that culvert. And then we can improve the capacity of the two southern culverts on that same roadway. We can improve their capacity potentially to help and drain the area behind this roadway. Additionally, Wind Bayou during this event overflows into this area behind the roadway. So we could build the berm along Wind Bayou a little bit higher to prevent flow from Wind Bayou into this area. So those are just some of the ways that we're using these models, the kinds of things that we're looking at. And so now we'll move into our general findings in this watershed. So obviously of note, this is a rural area, at least relative to some of the southern portions of the parish. Most of the streams in this area are natural, so they're in their natural state. They're not channelized or rerouted, and they really haven't been deepened. Highways are the major controlling features in this area, and the upper Comite tributaries and Sandy Creek watersheds are heavily influenced from runoff from outside the parish limits. On this slide, you see a map of all of the areas of concern that we found through our modeling up to date, and these are being assessed. And we have listed some of the solutions that will work in these three watersheds, or that should work in these three watersheds. So the first is floodplain preservation and stream setbacks. Because the watershed is so natural, or these watersheds are so natural, we can preserve what's there. We can also enhance overland flow routes. We can preserve the existing overland flow routes and enhance some, kind of like we saw in Upper Comite and Upper Amite, or Upper Comite and Sandy Creek. And then because highways are the major controlling features, bridge and culvert enlargements will go a long way in reducing flood risks. And finally, channel capacity improvements in the lower reaches will help to flush out some of that water from the large outside of the parish areas. And I think that is all I have tonight. Thank you for listening, and I'll pass it back to Melissa.
Thanks, Brandon. So I just want to give an overview of what projects have currently either ongoing or been approved to date. Brandon talked about some of the things they're looking at in the northern watersheds here, some of the potential projects. I'm just going to talk about what some projects have already been approved. Currently, there's maintenance of the existing system going on, and that is really of the subsurface system. They're doing cleanouts of structures and the pipes based on our previous evaluation and 311 calls. They're also intending to do more of this next year with American Rescue Act funds, not only the subsurface system, but also the channels. And then there's a number of hazard mitigation grant program projects that have been approved. And if you look on this slide, the picture in the upper right, that is the Comite River at Port Hudson Pride Road. And there's concern about bank erosion along that road. So one of the projects that's been approved is to do embankment stabilization along there to protect the road. That's one of the hazard mitigation grant projects approved. There are 6 others. And then there's also 3 Louisiana Watershed Initiative projects that have been approved. And you can see on the lower right of this slide, that is one of those projects. That's Bayou de Planche floodplain preservation. And we intend to do some of that similar up in these watersheds. And then there's also some low impact development policies that have been approved. And I'm going to let Stoka talk about that in a minute here. Other things the parish has been doing are home buyouts of those repetitive and severe repetitive loss projects. And then there's other projects ongoing in the watershed by others. The Corps with the Comite River Diversion Project, and the Corps also has the East Baton Rouge tributaries projects in which they're going through and doing clearing and snagging and some channel improvements. And I just want to point out that all those projects to date have been 100% federally funded. So that's over $96 million of federal funds going through to these projects. And we're hoping as we go along, we'll be able to identify that funding for additional projects as we go forward. And now I'm going to turn it over to Stoka Brown, who's going to talk about the codes and ordinances and the policies that we're looking at for the parish. Stoka.
Thanks, Melissa. As Melissa said, my name is Stoka Brown. I'm with CSRF. We looked at changes to the codes and ordinances. Initially, when the project began, the parish tasked us was trying to look at any interim changes that we could make while we were going through the process of looking at more larger changes. So some of those things that we were able to implement and were passed by the parish council earlier this year was to add a stormwater conveyance check as a part of the drainage impact study for certain developments that occurred near some of the major channels within the parish to ensure that they did not affect the flow rate of water downstream. We looked at trying to prioritize and incorporate green infrastructure pieces where they would be implementable in different projects. And finally, we looked at clarifying some of the code in order to make it clear to the public the purpose of these codes. So next, in terms of the larger changes that we're currently working on, the modeling that Brandon showed you is a powerful tool. And we're additionally using that tool to understand how changes to the code could help prevent increases in flood risk. And it's important that we do this because the changes that are coming in the capital improvement plan, we want to try and preserve those into the future and not counteract them. So a couple of those things that we are currently looking at are increases to the minimum slab elevation in reference to the base flood elevation. We're also looking at trying to protect the natural floodplains, looking at stream setbacks, looking at different preservation areas that are necessary to preserve the flow of water through the system. In addition to the preservation of the flow of water through the system, fill requirements are also being looked at in terms of really trying to understand where and how much fill can be placed in different areas of the parish and how that affects the flow of water through the system. Additionally, we're looking at the general drainage requirements for development in terms of the internal systems, the drainage system of the development itself, the availability of the overland flow path through the system, as well as the requirement in terms of size of the detention pond.
Thanks, Stoka. And the last thing I want to talk about is the overall schedule. We started this project intensely in January 2020. And on the left, you see the major tasks that are part of the program. And then where we are on the schedule is indicated by this red line. So you can see that all the data collection work has been completed. We've completed the building out of our models and assessing the existing conditions. We're currently working on developing those flood risk mitigation measures, as well as those policies that result in changes in codes and ordinances that Stoka was talking about. And then the stormwater management report expected to be completed later in 2022. And taking all of those capital improvement projects, we're going to develop a 20-year capital improvement plan, which the intent is to find financing and/or funding for those projects and lay that plan out over the next 20 years. And the last item that we have is the public outreach, which has been part of the program since the beginning. And I'm going to turn this back over to Claire, who's going to talk about a little bit more information on how you can become involved.
Thanks, Melissa. So a lot of good information here. We continue to accept your feedback, your comments, questions, anything you might have for the project team. And the way you can submit that, if you're not submitting it here tonight during this meeting, is via email, info@stormwater.brla.gov. You can post pictures and comments via social media using the hashtag EBR, Stormwater, or you can send them directly through the messenger on social media. And we also are accepting comment and questions via our website. So it's a similar, the system you use to ask questions tonight and to register for this event is the same system we accept comments and questions at any time. So we are tracking all of that. We want to be able to track the zip codes and everything that you guys might submit to us. So a reminder that right now you could submit a question or a comment via clicking the Join the Podium button. If you do not see that button, that may mean that you enlarged your screen and you need to click the little button of the segmented box and reduce it, and then click the Join the Podium button. But to get us started, we do have one question, and that is, if you guys are ready, what is the status of the Comite River Diversion Project, and how does this project affect the watershed, our watershed?
I'll take that. So we're not directly involved with the Comite River Diversion Project, but based on what the Corps is telling us, they're telling us they'll be completed in 2022. What we are doing is we're taking that design and incorporating it in our models, in the regional model, which does impact this northern area, and in some of the other watershed specific models. We have not finished incorporating that model, so we're not able to tell you specifically what the impacts will be, whether that's positive, negative, though overall we do believe there will be a significant positive impact. Anyone else want to add to that? Stoka, Brandon?
I think you covered it, and I believe potentially there'll be more to talk about in the regional watershed meeting. This is just specific to the individual watersheds themselves.
Okay.
What collaboration is happening with the surrounding parishes, if any?
So we have, there is collaboration going on for sure. We have a designated group, what we call our partners meeting, and that includes the surrounding parishes, the impacted municipalities, Baker, Zachary Central. It also includes the other entities, the Corps, FEMA, Watershed Initiative, and Amite River Basin Development Commission. So we do engage with those entities. We are currently specifically working with Ascension Parish in the lower area of the watershed on the Bayou Manchac area, because that area impacts Ascension, Livingston, Ascension, East Baton Rouge, and Iberville. So we're collaborating specifically there. But we've had a meeting with them initially to explain the project, what the process is, where we're going. And our intent is to have another meeting with them in the very near future. We wanted to get through this flood hazard assessment so we can kind of show them what's been done to date and where we're going.
What role, I'm sorry, are you done, Melissa?
Okay. Nope, that's it. Thanks.
What role does keeping culverts clean play in the stormwater master plan?
It honestly depends on where they are, but it is very important in terms of maintenance overall in general. To keeping the system clean allows the water to get into the system and flow through it like it was designed. I will say there are some areas where a clogged drain doesn't make that much difference, but we are intending to get the system cleaned, and we are identifying actually very specific structures that have a critical impact on the flow of water. Like Brandon showed earlier, the culvert at Plank Road, where everything needed to flow through it. So that would be considered a critical structure to make sure we're maintaining, because if that one was clogged, you would have a serious impact. And I do want to say that as part of this project, and in working in collaboration with the environmental services group, who is in charge of the MS4 permit, which is that kind of over stormwater management permit and keeping the system clean. So there is collaboration going on with them with the intent to establish a consistent maintenance program going forward.
Thank you, Melissa. We have a question about litter, and I believe what you just stated cover it, but I'll read it. And if you want to elaborate further, you can. Litter is a significant factor in flooding by creating dams and limiting flow. How are you going to incorporate this issue, and what solutions are you going to implement?
Well, the maintenance program, as we talked about, but I think that's also a larger, almost a public involvement or public engagement program that the parish needs to establish. And I think they have, I don't know, Claire, you can correct me if I'm wrong. I thought I've seen the parish engaging in a litter program for, just to educate the public on the importance of picking up litter.
Yes, I believe they have, Melissa.
All right, should you have any questions, please click that join the podium button, and you can submit your questions for the project team for tonight's meeting. Our next question is, are there any plans to dredge the Amite as a part of the Stormwater Master Plan?
That would be no. We're not really looking at the Amite River specifically. We're trying to address the impacts of flooding from the Amite River, but not addressing Amite River specifically. It's a much larger, river that impacts Livingston, Baton Rouge, Ascension, parishes to the north, etc. And that's really in the purview, I would say, of the Amite River Basin Development Commission and or Corps of Engineers type level project.
A final question at the moment is, will this information be made available to the public once the plan is completed?
Absolutely. I mean, the whole intent is to engage the public and make sure that they know what is going on and that their input is taken into consideration. So I don't know if you mean this specific public meeting, which will be put on the website, but yes, there will be definitely available to the public.
All right. Well, it seems that we don't have any more questions. If you want to sneak one in while I'm closing this thing up, then go for it. So as Melissa said, this presentation and all this information will be available. The information in the presentation will be available on our website. And that is stormwater.brla.gov. We will still be accepting questions, comments, feedback via the places I mentioned earlier, our website, stormwater.brla.gov, email address, info@stormwater.brla.gov. I mean, could we make it any longer? I'm just asking. Social media, hashtag EBR Stormwater, and all those other good ways. If you want to get in touch with us and you have a computer, you can do it. So other than that, questions? All right. So thank you so much for joining us this evening, and thank you, project team, and the members of the city who joined us. And we will see you guys in 2022. Thank you. Good night.
Thanks.